Here. Just a minute. Yeah, we're here. All right, good. I just had to double check because sometimes I don't know. All right, so here we go. Here's our homework. All right, and so you get 3 attempts. If you eat a Snickers bar, which has 271, how many kilojoules is that? Remember, 1 calorie is equal to 4,180 joules, and a kilojoule is equal to 1,000 joule. All right, I took my answer to 3 sig figs, but I think I've given lenient parameters, so it should be okay if you put all the numbers in there. That's going to be. So do you remember how we did that? What that looked like? Okay, that was like on page 1 of the notes. Yeah, we did that already. So if you can burn off 33 kilojoules per minute playing pickup soccer, how long are you going to need to play soccer to burn off that Snickers? I've rounded this to 2 significant figures, but again, I've given pretty lenient parameters. In other words, plus or minus like 10 or something like that. Okay, so 33 kilograms per minute. Now, here's what I wanted to show you. So here's problem 2. Let me write down the info for it. So soccer burn rate, it's actually the power using soccer, because this is joules per minute, is 33 kilojoules per minute. All right. And the Snickers bar, well, I'm going to probably blow it here and tell you what the answer is on that. But anyway, so let's take a look. Wait a minute. 271 calories. So taking your answer from problem 1. So you get your answer from problem 1. And I do this a lot. I build on things. So what you got in the previous thing. Some students found that very frustrating because they're like, God, that problem kicked my ass, and now I don't have the answer to go on to the next one. Well, you figured out. So answer from 1. So you take the answer from, now look what we got. I need to get minutes. And my answer from 1 is actually, did my pen explode? Looks like. My answer from 1 is actually X amount of kilojoules. Okay, it's X amount of kilojoules. So if I take 33 kilojoules per minute, and if I take this amount and divide that by 33 kilojoules per minute, look what happens. I bet you never thought why you divide by the reciprocal when you learned that back in like 5th grade or 5th or 6th grade with fractions. But here you're doing it. So X, which is your answer to 1, kilojoules, over 1, times, now you take this fraction, minutes over 33 kilojoules. There you go. Look at that. The kilojoules units cancel, and you're left with minutes. That's your answer. That's what you're looking for. Okay. All right. If Usain Bolt ran 100 meters in 9.68 seconds, what was his speed in meters per second? All right. Well, you can do that. 100 meters, 9.68 seconds. That's his average speed, by the way. At certain points, he was going 13 meters per second when he first busted out of the gates. The guy's amazing. Let's go backwards. What was Usain Bolt's speed in miles per hour? All right, so I'll help you with this one. 3, easy. See, here we go again. 3, easy peasy. Okay? Now, we've got meters per second. Now we've got to get miles per hour. Okay? So in problem 4, you've got meters, you've got your answer, X again, meters per second, which is what your answer was from 3. All right? And we want to change that to miles per hour. Well, we already know that going from miles per hour to meters per second, I multiply by 0.447. So if I want to go backwards, in multiplication, what do? That's right. I'll divide. So you take X meters per second divided by 0.447. which gives us miles per hour per meters per second in meters per second. Then my meters per second cancels. Oh, it's meters per second per miles per hour. Then my meters per second cancels and my miles per hour comes up here, and that gives me the miles per hour. All right, I think I'll squeeze one more problem in on here. Okay, what internal temperatures do things start to become dangerous for the human body? Oh, okay. I really didn't go over, so at what, I think it said on that slide that it becomes at 104 degrees. Okay. All right, so question 6 is just use your common sense. Okay. Then question 7, these next week we're going to see what a wonderful mechanism the human body actually is. All right, so I'm going to actually work with you on this one, and I want to start with a fresh slate.